Hello, my name is Diego Vadillo, and for my Unit 7 project, I created a device which is a car that is made out of popsicle sticks, wooden sticks, straws, bottle caps, tape, and glue. And in order for it to work, it uses rubber bands. So this car is uses kinetic energy, potential energy, mechanical energy, and elastic potential energy in order to work. So, so this car works and it moves when you put the rubber band in the two hooks, which are here in the wheel axis, and you wind it like a toy robot. And when you wind it, the elastic potential energy causes, when you let go, it causes it to make the wheels from behind roll, and that movement makes the car to move forward without me pushing it like this. Okay, so some constraints that were noticed in this device while I was experimenting it was that the car was too lightweighted, so it wasn't able to move correctly when the rubber band was let go for it to move, and the wheels were too smooth for the surfaces. So I had to put rubber bands around the wheels for it to cause a friction in the surface in order to move and not sliding. The application of scientific knowledge and engineering design can decrease the risk and the cost in modern civilization, because when you have the knowledge of science and engineering, less trials will have to be done, because you know what things work and what things don't work. So an example is like with this simple car. I knew how the potential energy worked, how kinetic energy worked, how elastic potential energy worked, and how the friction of the wheels was not go how the friction of the rubber bands was going to work. So it made my process easier, shorter, and more efficient. While for the cost, I only had to test one car because of the knowledge that I had of how it worked and how what were going to be my constraints. If people apply this knowledge and this engineering design process in modern civilization, uh, less money would be spent on different prototypes. I'm not saying that prototypes are wrong, but like the prototypes each time will be more efficient and less failure, and the risk will be lower, because if you already have the knowledge, you know what things are going to be dangerous and what things are not going to be dangerous. Okay, so this device was tested by measuring the distance that I traveled depending on the turns that the rubber band had around the wheels. I measured the distance in centimeters with that uncertainty of 0.01, and I measured the turns with degrees. So one turn meant 360 degrees 2 turns 720 degrees and 3 turns 1080 degrees. My variables in the device were that my independent variable was the amount of turns of the rubber band in the wheels, and my dependent the variable which depended on the amount of turns in my car was the distance traveled in centimeters. The way that I designed the test was that my criteria was that my car was able to move using the power of the rubber band. So the way that I designed it was by measuring the centimeters traveled by it, and depending on the amount of turns that the rubber band had on the wheels.